Hello everyone, welcome to our first tutorial on OpenCV. We're going to have a series of tutorials on OpenCV. The first one, I'm going to discuss some basic commands that can be used to load images, videos, and process them. But let's begin with OpenCV, what it is. OpenCV stands for Open Source Computer Vision. It's a library that offers you simple commands that you can use to load videos, images, and process them. Throughout the course, we talked about several image processing tasks such as image thresholding, segmentation, object detection, or we will talk about them towards the end of the course. OpenCV offers commands that you can use to carry out these tasks. And it has you're able to code with C++ or Python OpenCV, and it's up to you to pick which one. We're going to use Python throughout the course. In terms of speed, the OpenCV for Python and C++ are almost the same. Obviously C++ is a bit faster, but essentially the OpenCV library for Python is a wrapper around C++ code, so it's almost as fast as C++ library. Now let's begin with writing some basic codes. I'm using PyCharm as my IDE for coding in Python. You can use any IDE that you prefer, Jupyter or anything else. First, I've created an empty project called image processing, and it has an empty file in it called reading images, and I have put an image in there, HZ input. It's this image that I'm gonna try to load and modify it a bit using OpenCV. Now let's start. We need a couple of modules. First one is OpenCV. We can import it as CV2. We also need NumPy. I'm going to import NumPy as MP. Obviously you have to install these first. If you go to settings under the project, you can add these. You need to search for NumPy and install it. I have already installed it. And you need OpenCV. It is OpenCV Python, and you need to install this as well. Now we're set and we can start. First thing you want to do is import an image. How can you do that? That's the most basic command in OpenCV. It's called imread. Let's read that image that we already have in our folder. We use cv2.imread command, and it takes two inputs. First, the file name, and its format. Make sure to include this. Here the file is in JPEG. If it was PNG, we input PNG. And then it takes one number. It could be 0, 1, or -1. 0 means it will try to import the image in as grayscale image, and 1, it tries to take the image as colored. So if the image is colored itself, it tries to take it as color. If we said -1, it takes the image as whatever it is. If it's colored, it will import it as colored. If it's grayscale, it will import as grayscale. Obviously, if you give it a grayscale image and ask it to import it as colored, it won't do anything. Now let's first try to import it as grayscale. And let's print this, see what it is. I'm gonna run this. So you can see we imported the image and read it, and it turns out it is just a matrix. It's an array with different values for each element of this array. That is what an image is. If you remember, we discussed in the course, an image basically is a matrix, and each pixel on that image represents an element in a matrix. Now to understand a bit more, let's figure out what is the size of that image. To check the dimensions of this image, we check the dimensions of that array that we just loaded. So to check the dimensions, I check the shape of that array, and I also want to know what type of data is inside that array. We can get the height and width of the image as well. Now let's run this code, and I'm gonna print these values. So the first is the dimension. It's 480 by 640. So that image has 480 times 640 pixels inside of it. They are in 480 rows and 640 columns. Data type. Each one is an unsigned integer with 8 bits. And it makes sense, as we talked about, each pixel can have a grayscale value or color value between 0 to 255. When it's grayscale, it shows different concentration or shades of white and grayscale. So it takes a value between 0 to 255. So the data type must be, for an image, unsigned integer with 8 bits. And if you check out the values in this image in the array, it's all between 0 to 255. The width of the image is 640 and the height of the image is 480. If you look at the image, you can see it is 480 pixels by 640. And after you load an image, you can also show it inside this in the Python. To show the image, we have to use the cv2imshow command. It takes again two inputs. First is the name of the window you want to open. Let's call it window 1. And then it is that array that represents the image. We named it imgimage. So when it shows an image, it shows it for an infinite amount of time. To make sure it closes after a few seconds, we use the wait key command. Wait for about 5 seconds and then close the window. Sorry, wait key, the key should be caps. So we loaded the image as grayscale, waits a few seconds and then closes it. So we can load any array as an image using imshow command. And the thing is, any array can be loaded as image, but it only will show an image, meaningful image, if the data types of that array are unsigned integer. If you give it an array that has values more than 250, or the data type is even not set to unsigned integer, for instance, it's double, it's not a meaningful image. You will see a blank white window. So now that we have learned how to load and show an image, let's do some other things with it. You can always save it on your computer as well. If you want to save an image, we can use the cv2imwrite command. Again, it takes two inputs. First is the name of that image you want to save. Let's call it image test, and what type it should be. I want to save it as PNG this time. And the name of that array that you want to save as an image, we call it image. Let's run this code. and now it's saved on my folder image test. It is PNG file. It was originally colored. I loaded it as grayscale and saved it as grayscale as well. Now there are other things you can do. When you load an image as an array, there are lots of things you can do with it. But some built-in commands that in OpenCV are for changing the color space of an image. To show that, let me first start with loading the image as colored. So far it was grayscale, right? So let me load it as colored now. I'm gonna remove the rest of the code and just show it loaded as colored. Let's see if it's a colored image now. Yeah, now I'm loading it as a colored image. So there are commands for changing the color space. For instance, if you have a colored image and you want to make it grayscale, let's call it image number 2. And for converting in the color space, we use CVT color. So converting to a different color. We have to first give it the array that it want to use as image, and then what color space should it be. For instance, I want it to be from if you put color here, it all shows all possible conversions. So for instance, I wanted to turn it into grayscale, and then show the new image. Now it's grayscale. So I loaded the image as color and converted it to grayscale. One thing that you have to notice that when in OpenCV you load an image as a colored image, instead of RGB, it is BGR. So it loads it as blue, green, red. That's why it's called BGR instead of RGB. That's the thing about OpenCV. Now also let's look at the initial colored image. So as we said, image is an array, but what is a colored image? A colored image is made of 3 arrays. 3 arrays that are concatenated alongside each other. The first array shows the blue color. As I said, OpenCV loads them as BGR format. So the first array shows shades of blue, and it is still unsigned integer with 8 bits, values between 0 to 255. The next array shows green, shades of green. The last array shows shades of red. So if we print again the shape of this new colored image, you see it is 480 by 640 by 3. So it's like 3 arrays alongside each other, each for a specific color: blue, green, red. And then when I converted it into grayscale image, it turned it into just one array. See, it's only one. One last thing I want to talk about is OpenCV has lots of built-in commands to do specific tasks, like these converting colors. You can convert image with one color to, like, for instance, grayscale, or from BGR turns into another different color mapping. Additionally, you can do them yourself. You don't have to rely on OpenCV commands. OpenCV commands are optimized to do a specific task as fast as possible, but you have the option to do it yourself. For instance, when we load a color image, how can we turn it into grayscale ourselves? As I say, it has three arrays that are each represent a specific color. One way to turn it into grayscale is to average each color. Average the first array, second array, and third array. Then you get one number between 0 and 255. Then it would be grayscale. Let's try doing it now. I have the color image and I want to manually change it into grayscale. Let's see if it's a grayscale. Sorry, still use the coding in MATLAB. So what happened? Let's look at the image. So it just gave us random noise, right? Let's look at the image. Sorry, I want to print it. Let's see if we can spot what is the problem. So the array that I made by averaging these three images, it looks like something like this. You can instantly see the problem. These are not unsigned integers, values between 0 to 155. These are decimals. So when you want to show it as an image, it doesn't understand what it is. Best thing to do is we can round them up and take the type of the data into unsigned integer. Let's try it. Now it's a grayscale image. Instantly you can spot the problem. The problem is that we tried to turn colored image into grayscale by averaging red, blue, and green colors. But that's a very naive way to do this. The way OpenCV converts colored image into grayscale is a bit more complicated. Green, red, and blue, they don't all contribute to the final grayscale color at the same level. By averaging it, we assume that, for instance, 33% of the grayscale color comes from red, 33% from blue, 33% from green. But that's not true, and it's a bit different. So if you want to improve this, and the way it actually is, about 10% of a grayscale color comes from blue, about 60% comes from green, and 30% is from red. Now let's see how it looks. It's much better. So the point was that you can try to manipulate images yourself or use the optimized code that exists in the OpenCV library. One last thing I wanted to talk about is the OpenCV tutorials that are available online. If you search for OpenCV tutorials in Python or go to this web page, this link is available on our Learn web page as well. You have access to lots of OpenCV tutorials, and they start from the basics, some of the things we talked about, load images, to more advanced image processing and video processing algorithms. You can go through these if you want. And usually there is no need to memorize these commands that we talked about. You just look up them and look up these commands, and they are available online. And you have access to lots of tutorials, how to process images, change color spaces. This is something we briefly covered, and from even to video analysis or more advanced topics such as how to implement machine learning algorithms with the images that are loaded through OpenCV.